T-minus 10, go for main engine start. We are go for main engine start, T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
This was the picture that NASA managers all over the world were waiting for.
The Hubble Space Telescope is released.
The clearest pictures ever seen in the history of astronomy.
Scientists expect it will revolutionize our understanding of how far we have come and still have to go. How far we have come.
381 miles above the Earth.
We see stars, blobs, pillars.
Floating in orbit, the Hubble Space Telescope.
Each one tells us
how far we have come.
When the Hubble Space Telescope launched in 1990, it was a gigantic leap forward.
Hubble was something that scientists dreamed about having for decades.
Reporter Brian Resnick.
On Earth, we can put telescopes on mountaintops, but space, putting a telescope in space, that's kind of like the ultimate mountaintop.
And from its orbit around the Earth, Hubble revolutionized our understanding of the universe.
Hubble taught us that the universe is expanding faster and faster all the time. It helped us determine about how old the universe is. And this is not a small thing. It's given us these ridiculously beautiful images, the Orion Nebula, the Deep Field, the Pillars of Creation.
But now we're on the verge of a new era.
This is the future. NASA's James Webb Space Telescope.
The Webb Telescope, which is named after a former NASA administrator, is the biggest, most powerful space telescope ever built.
It's a grand scientific undertaking, a space telescope so sensitive it can peer deeper into the cosmos than any previous orbiting observatory.
Our reporter Brian's been talking about the Webb since we launched this show, and he's been speaking to tons of astronomers who all have research projects lined up.
This is really the reason why I wanted to bring it to the show, because this is a machine for answering unanswered questions.
I definitely think that Webb will be a paradigm-shifting telescope.
We're going right up to the edge of the observable universe.
The Webb represents the culmination of decades, if not centuries, of astronomy.
We will find things that completely surprise us.
It'll give us a view of parts of the universe we've never seen before.
Things that fundamentally change the way that we understand the universe.
I'm Noam Hassenfeld, and for the next 2 weeks on Unexplainable, we'll be diving into the question-answering machine that is the James Webb Space Telescope.
How far we have come and still have to go. How far we have come.
each one tells us
how far we have come and still have to go. How far we have come.
each one tells us
how far we have come.
Okay, Brian, before we get to some of the unanswered questions that the Webb telescope is going to let scientists try and answer, let's just start with the telescope itself. What makes the Webb so powerful?
So I talked to Amber Strawn. She's a NASA astrophysicist. She's worked on Webb for years. And she really pointed out there are two key ways that the Webb improves on Hubble.
The first way is really just the size.
It's enormous. It's much bigger than the Hubble.
Hubble's about the size of a school bus. Webb stands about 4 stories tall. It's about the size of a tennis court. So it is absolutely huge.
And bigger with a telescope is inherently better?
Yeah, so especially when it comes to this kind of telescope, the key component is the mirror.
So a telescope mirror, you can sort of think of it like a light bucket. So the bigger it is, the more light it can just collect.
And Webb has this light collecting area that's more than 6 times bigger than Hubble.
And then also the bigger it is, the finer resolution it can see.
And not only is it large, it's like a gorgeous golden honeycomb with all these different segments of hexagons.
Mm-hmm.
Here, let me send you.
Oh, cool. I mean, this looks like something that I would see in a sci-fi movie and be like, oh, wouldn't it be cool if they made things that looked like that?
Yeah, and they did.
And because it's so big, there aren't any rockets that are big enough to launch it fully deployed. So the whole thing has to be folded up to fit inside a rocket.
The engineers had to find a way to kind of origami it into a smaller package so it can actually fit on a rocket ship. And then once it launches, it will have to assemble itself in space. So
I'm sorry, assemble itself?
Yeah, it's supposed to.
So that whole process of building a deployable telescope in space is sort of the source of a lot of the engineering challenges.
Okay, so the Webb is super big.
Mm-hmm.
What's the second important difference between the Webb and the Hubble?
The type of light it collects.
Webb is an infrared telescope, so that means it sees the universe in infrared light that's a little bit more red than what our eyes can see.
Hubble can detect visible light, which is what our eyes can see, but Webb can see what's invisible to our eyes.
And as far as all the frequencies of light go, red's at the lower end of the spectrum, right? Like longer wavelengths, lower energy?
Yeah, so light comes in a lot of different flavors. So blue would be very high frequency. And then if it gets lower and lower frequency, it gets redder and redder and redder. And then it drops into infrared.
And what's the advantage of having a telescope that can see infrared?
This relates to something we were talking about a couple of months ago on our episode on Henrietta Leavitt and the end of the universe.
Okay.
We talked about how the universe is constantly expanding, right?
Right. More space all the time.
So scientists discovered that by looking at the quality of light coming from different parts of space. And it turned out things that were farther away from us looked redder than the things that are closer to us. This is called redshifting.
Space is expanding, and as light travels through space from those distant galaxies, the light is literally stretched by the expansion of space.
Imagine a star that's really far away, and the light from that star to get to us has to travel through space. But that space itself is expanding, and that space is stretching the light until eventually it gets so red, it drops into infrared. And what that means here is that Webb, because it collects infrared light, it can see these very far away things that Hubble just couldn't see. Things that are so far away, the light might have started off in the visible spectrum, but is now infrared.
So the Webb will literally be seeing things that are so far away that no one's ever seen them before.
Yeah, infrared telescopes are really sensitive.
And because of that, the telescope has to be very, very, very cold.
Because anything that is warm will glow in infrared.
You and I, all your listeners, we're all glowing in infrared light. If the telescope was warm, it would just glow and see itself.
So to keep it cold, the Webb actually needs to be sent really far away from the Earth.
Webb is going to be 1 million miles away. That's about 4 times further than the moon.
What? It's going to be in a place where it's shielded from the heat and light of the sun and the Earth.
Sorry, 4 times the distance of the moon?
Yeah, really very far. So this is not going to be orbiting the Earth. This is going to be orbiting the sun, but also keeping itself in line with the Earth. It's called a Lagrange point.
So it's orbiting the sun with us, but like at the same pace that we're orbiting the sun?
Yeah, it's pretty wild.
That is insanely cool.
And when you add all those together, the size of the mirror, the wavelength of light it will see, what we're going to get is a telescope that's about 100 times more powerful than Hubble, if you can even imagine that.
This is a super high-stakes mission. The Webb, it's going to be nearly 1 million miles away. And once it's there, we can't fix it. And what's haunting this whole project is that the Hubble needed to be fixed. After it was launched in 1990, the images from it just came back fuzzy.
But I am extremely concerned by the fact that after spending almost $2 billion over a 12-year period, we only now find out that this kind of mistake could occur.
And it was kind of this national joke.
Have you heard about the problems with the Hubble Space Telescope?
Yes.
$1.5 billion, we put up a telescope, and it's out of focus.
And so astronauts had to launch on a space shuttle and fix it, give the Hubble reading glasses, so to speak. And they could do that because Hubble was close enough to the Earth where you could launch a shuttle and get there and fix it.
And they called the NASA official repairman. And he said he'll be up there sometime in the 21st century between noon and 5.
You build the greatest, biggest telescope that humanity's ever assembled, and it's like, it's blurry.
Yeah. But you can't just go and fix the Webb if it breaks.
Right.
It's way too far. it just has to work.
Yeah, so have they been sort of like double checking everything, like waiting
Yeah.
a while to make sure they're not making any reading glasses mistakes?
Yeah, it's just taken such a long time to get here. People were talking about the successor to the Hubble before the Hubble even launched.
Mhm.
And the James Webb Space Telescope was originally supposed to launch in 2010 and cost around $1 billion. Now the costs have ballooned to $10 billion, and it's just way overdue.
And they're still planning to launch it, right? That's the plan?
The plan is to launch by end of 2021, and this can change. So don't at me if it does change. And then after it launches, there will be some time, like it has to deploy, has to do all these things that we talked about.
Unfold in space.
Yeah, fingers crossed. But then, the science will start. And this is one of the things that really drew me to the story, is that anyone can use the Webb Space Telescope.
What do you mean? Like there's like a terminal somewhere that you can walk up to and like check out space?
Yeah, put your eye next to it.
Put in a quarter?
No, anyone in the world can write a proposal, say, I want to use Webb to look at this.
Can we use it?
Yeah, I wanted to know too. I asked Amber at NASA.
Absolutely. I mean, you might need an astronomer friend to help you out.
Should we apply?
I looked into it, and I think it's a little bit over our heads to do this.
Yeah, it's pretty competitive, to say the least.
So in March 2021, the Space Telescope Science Institute, which runs the Webb and other space telescopes, they sent out emails to scientists who had applied to use the Webb. And these scientists were on this day were furiously checking their emails to see if were their proposals accepted. And it was kind of all huddling around and finding out who got parts in the school play.
Okay.
It was an exciting day.
We totally felt like underdogs.
It feels like a dream.
It was honestly a truly amazing feeling.
I think I was just stunned for a good minute there. I probably cried a little bit.
I'm pretty sure I jumped up out of my chair in my office and shouted out, "Yes!"
And Brian, you've been talking to these scientists for the last few months, right?
Yeah, I've been talking to scientists who have been awarded time to use the telescope, and these conversations, they just leave me with a big smile. Just their sense of wonder and awe. These are people who get to explore the frontiers of the cosmos, and they just have so many unanswered questions.
What kind of questions are they trying to answer?
Questions about the search for life in the universe, questions about the beginning of time, about exploring strange new worlds that are way different than anything that exists in our solar system.
How strange?
Oh, I'll tell you, but just after the break.
Yes!
It's a lava planet.
Let's go to space, go into space. Can't wait, space, going. Better buy a telescope. Want to see me? Buy a telescope. Gonna be in space.
Unexplainable. We're back. So is Brian.
Hey.
And we're talking about the upcoming James Webb Telescope and all the unanswered questions it might allow scientists to answer. So Brian, what's the first unanswered question that scientists are trying to figure out with the Webb?
Is there life on other worlds?
Big one to start with.
Yeah. And, they're looking for life, and not, necessarily in our neighborhood, on Mars or Venus, although there are searches for life on those planets. But they're looking for life on worlds called exoplanets, which are planets that revolve around stars that are not our sun.
So planets in entirely different systems?
Yeah. And scientists in the last decade or so have detected so many of them. There's just been this exoplanet revolution. But we've detected them with smaller telescopes, and it's just hard to know a lot about them. We just can't study them super well, but that's going to change. The Webb is going to give us a whole new view onto exoplanets. And I talked to an astronomer, Lisa Deng. She's a PhD student at McGill University, and she's been awarded time on the Webb to study an exoplanet.
This is the first telescope proposal that I ever submitted that was successful. It made me feel like an astronomer for the first time.
What kind of exoplanet is she looking at?
Oh, this is so rad. So I was looking down the list of of projects approved for the Webb, and I just stopped at Lisa's because she's going to study one of the most extreme planets we've ever discovered.
I want to use this James Webb Space Telescope to look at K2-141b, the lava planet.
A lava planet?
Yeah, like when we get outside of our solar system, planets can get really weird.
It probably looks like hell.
So we know this planet is there, but we really don't know much more about it. We just haven't studied it in detail because we just haven't had a big enough telescope. So I asked Lisa to help me imagine what could be there.
Oh, I have so many mental images of what this planet could look like.
This planet, the first thing to know about it is it's really close to its star.
It's so hot on this planet that you could sustain a temperature that would melt the continent on the planet.
Anything on that surface is just the hottest thing you can imagine.
So instead of having oceans of water like we have here, we have oceans of lava on this planet. The floor is lava.
But then there also could be weirder things. So like this world isn't like an uninteresting place.
So things that I'm hoping to look for is maybe clouds on this planet.
But they wouldn't be like any clouds you've ever imagined before.
Instead of having, clouds of water molecule like we have here, these planets would have clouds made of rock.
In these clouds, even if they're made of rock, they can still float because the particles in them would be small enough.
It's probably looking pitch black, like dark black clouds, but depending on the shape of these particles, maybe they could be shinier cloud of crystals.
And then those clouds, they can do cloud things.
We can also have rain from these clouds. It would be raining rock or like raining silicate.
It's truly one of the most extreme places we've discovered in the galaxy.
Okay, the lava planet seems really cool and all, but why is the lava planet the place to start if Lisa is trying to search for life? It doesn't exactly seem like a place where there would be life.
Yeah, it is a very extreme place. If life exists there, which is unlikely, it would be unlike any life that we can think of. But there's a bigger picture reason why she's studying the lava planet. It's because it's the perfect place for her to get really good at atmosphere hunting.
Atmosphere hunting?
So we don't know whether these planets even have like an atmosphere like we described on Earth.
But in order to find life, like anywhere, we're pretty sure a planet needs to have an atmosphere.
Mm-hmm.
And the lava planet is just this like big hot place that glows in infrared really brightly. So it's going to be really visible for the Webb Space Telescope. So it's just a perfect place to like learn how to study atmospheres on other planets and really refine the skills of analyzing them.
So looking at a lava planet is kind of like the first target that you want to try with James Webb before you go towards more temperate, rocky planets like Earth, for example.
And how exactly would the Webb figure out if a planet has an atmosphere?
So what I am hoping to do with the James Webb Space Telescope is basically to observe this planet as it completes a whole orbit.
When the planet crosses in front of its star, it will come in between the star and the Webb telescope. If there's an atmosphere there, that atmosphere will change the quality of light. So the atmosphere would act as a sort of filter. And then from there, like Lisa can actually create these whole weather maps of the planet.
So is she basically going to have to do this like one by one, point the Webb at every single planet to see if it has an atmosphere?
Hopefully she doesn't have to do that all by herself. She's not alone here. She's not the only scientist studying exoplanets.
I spend most of my time not quite staring up at the stars, but trying to reveal their secrets.
I talked to this guy, Kevin Stevenson. He's a planetary scientist at the Johns Hopkins Applied Physics Lab.
It's exciting, right? This is the first step towards answering the question of, are we alone?
He's also been approved to use the Webb, and he wants to know if he can predict whether planets have atmospheres or not before he even looks at them directly with the Webb.
How would you predict whether a planet would have an atmosphere?
So there's actually this really neat pattern that scientists find in our own solar system where they look at our solar system and they catalog all the planetary bodies, the planets, the moons, and they see which ones have atmospheres and which ones don't. And it turns out it's just a function of how big the planets are and how warm they are.
So this is a really neat trend that we see in our own solar system. And the question is, does this trend apply to systems outside of our solar system? Is it truly cosmic in nature?
There are potentially billions of planets to look at. And if we can just better predict which ones have atmospheres, then we can narrow it down. We're like a step further in the direction of answering the huge question, are there other habitable worlds?
And where do we go from there? I mean, where do we go from, okay, these planets have atmospheres to, is there life on those planets?
Once we have confirmed that a planet has an atmosphere, the Webb can actually detect things in that atmosphere that might be signs of life or clues that the planet is habitable.
We can detect water, CO, CO2, methane.
You can ask fascinating questions like, what created that methane? Could it be life?
If we want to look for a planet that's similar to Earth, we would probably want to go out and look for CO2 first.
It might sound like small, like, analyzing the atmospheres of different planets, but really this is going to be our first step to that ultimate question of like, is there life out there? Is there another Earth-like world? Is there a place that we could live on or something to live on?
There's most certainly life out there. The universe is large, the galaxy is large, there's billions and billions of planets out there. Life has to form. We've seen it form in the strangest places here on Earth, right? The question is, will we know that we're seeing life when we make that measurement?
There are just so many exoplanets, and we just don't know what's possible on these worlds. And the Webb is giving us this opportunity to really deeply investigate them for the first time, to fill in the coloring book of the planets of the galaxy.
It's a very complicated universe. I want to know where we fit into it all. Are we alone?
And this kind of enormous ultimate problem of are we alone in the universe is just one of these huge questions that the Webb can let scientists try and answer, right?
Yeah. Exoplanets are a huge source of unknowns, but there are other huge areas of unknowns too. Areas that have less to do with traveling through space and more to do with actually seeing back in time.
What do you mean?
The farther away we look with a telescope, we see older and older light. That light has just taken a really long time to get to us. And we can take these snapshots of a universe like long past, like as it existed billions and billions of years ago. So I want to tell you about this next week.
Okay.
Scientists who are trying to look back further than they have before, they actually want to point this telescope at a blank region in the sky that looks like there's nothing there. They're hoping to find the very first light of the universe.
How far we have come. And still have to go. How far we have come.
Each one tells us
how far we have come.
This episode was reported by Brian Resnick and produced by me, Meredith Hodnott. Noam Hassenfeld wrote the music and edited the episode with help from Jillian Weinberger. Mandy Nguyen checked the facts. Christian Ayala was on mixing and sound design. And unsurprisingly, Bird Pinkerton wrote an awesome article about Formula One for Vox this week, so you should totally check that out. Lauren Katz heads up our newsletter, and Liz Kelly Nelson is the VP of Vox Audio. You can sign up for our newsletter at vox.com/unexplainable and email any thoughts you might have about the show to unexplainable@vox.com. Unexplainable is part of the Vox Media Podcast Network, and we will see you next Wednesday for James Webb Part 2.